Yes. Hello again, and I think now we can continue with the next presentation, and it's a presentation from Build Robotics, and I think this you have heard today already in the presentation from Director Kessler, and you have seen a little movie in this presentation where Build Robotics has shown the solution. And yeah, and basically now I welcome Gaurav, who will give us a presentation on autonomous trenching solutions. And yeah, I'm looking forward to your presentation.
Thank you very much. Good afternoon, everyone. My name is Gaurav Kikani. I'm Vice President of Business Development and Strategy at Built Robotics. Very excited to be here and share more about what we've been working on as a company. And so what we do in a nutshell is that we build the robots that build the world. What that means is this is the next evolution of technology that we believe is going to really change how we build. And I think the best way to understand this is to actually see it in action. So we have a short video here that will give you a sense for the technology that we've created.
We build the same way our grandparents did, with our own two hands. But the tools in our hands change. Built Robotics has developed the most advanced tool available on any job site today, the Exosystem. It transforms any excavator into a fully autonomous robot made to dig the earth. It's powered by a liquid-cooled computer with sub-centimeter RTK GPS, high-efficiency solar panels, an all-weather, all-terrain design. And you can easily switch from manual to AI mode with a flick of a switch. But most importantly, it can dig. Does the idea of an 80,000-pound robot scare you a little? You'd be crazy if it didn't. That's why we've developed an 8-layer safety system with 360-degree camera coverage, proximity radar, 110 decibel safety alarms, ultra-bright LEDs, high-vis barriers, a digital geofence, and hardwired and wireless emergency stops. Because when it comes to safety, more is more. We're here because of the builders who came before us. They created the world we live in, our roads, our cities, our homes. And when they needed a tool to overcome a new challenge, they invented it. Now, it's our turn.
So that should have given you a sense for what we're talking about. These are fully autonomous robots. We take existing heavy equipment and we can upgrade it to enable full autonomous capability. And we'll talk a little bit more about the product in a second. But just to give you a sense for who we are a construction technology startup based in California, in San Francisco. We were founded back in 2016, and we have achieved a lot in that time. We have over 18,000 hours of autonomous operation to date with no safety incidents, what we're very proud of. We are a venture capital-backed company. We've raised over $100 million from some of the largest and most esteemed venture capitalists in the world. And we have a phenomenal team that sits at the cross-section of technology and construction. You can't have one without the other, and so we believe that you need to bring the best minds from both in order to build a tool that's actually useful for this industry. So what's the product? Some people ask us, are you building these excavators? The answer is no. We take existing heavy equipment that the largest OEMs, Caterpillar, Volvo, Komatsu, they build, and we can enable autonomy by installing what we call the Exosystem. And that's what you see here. The Exosystem is this unit that is comprised of a handful of different sensors, RTK GPS, IMU sensors, and we basically install that on this existing heavy equipment. And those sensors are basically what we use to collect information about the environment. So every second, we're collecting thousands of data points on what is the orientation of the excavator, where is it located, where is the bucket, where is the stick, and we can stitch all of that information together in order to make intelligent decisions on how to actually move the excavator. So the way the decisions are made is the software, and that's the core piece of the Built Robotics technology. So we have a team of roboticists and software engineers who have built this reliable software that runs on our onboard computer, and that software is basically sending signals to the excavator in order to actuate the hydraulics and actually move and dig the dirt and complete the task that the machine has been given. So that equipment upgrade process is actually a very simple, non-invasive process that we've developed. So the exosystem is mounted to the counterweight of the excavator, and it ties in to the onboard electronics of the excavator itself. We actually preserve the manual operation capabilities of the excavator. So we think that's very important. Robots will be very good for certain tasks, but from time to time, you still may need a human operator to jump in the cab of the excavator and take over manually. And for that, it's a very simple flip the switch, and you can take over manually. So we think that's strategically very important. It is a one-day install, so it takes a couple of hours to actually install this unit onto the machine. And then we also run a calibration process, because every machine has unique dynamics. And so we want to make sure we capture that. So we run a simple script, and we're able to capture all of that. And then your machine is ready for the tasks at hand. And it's also important to highlight that our system is compatible across OEMs and equipment sizes. So we think it's also very important that we are not dictating what contractors need to use, what type of equipment. We want to build a solution that will work with whatever equipment that you guys are using. The second side of our technology that's important to highlight is how do you actually communicate with a robot? So we install the exosystem onto the machine. The machine is now capable for autonomous operations, but a human supervisor still needs a way to communicate with the robot, and that's where our user interface comes in. So the user interface is a very intuitive software solution that we've developed. You can run it on a laptop or a tablet, and basically at the start of a day, a robotic equipment operator will come to the machine, they'll fuel it, grease it like they normally do, and they'll turn it on. At that point, you would launch this software application we call Everest on your laptop, and you can connect to the robot, and then you would communicate to it what task you want to complete that day. So as you saw in the video, trench excavation is something that our robots are very good at. And so the way this would work is that you would log into Everest, you would tell the robot, I want you to dig a trench from point A to point B. I want you to dig to 1.2 meters depth, and I want the spoils placed on the right side of the trench. You would give the robot the parameters for the task that you want it to complete that day, and then you press the start button. And once you press the start button, the robot will go to work, and it won't stop until either the task is finished, it runs out of diesel, or it runs into an error and needs some help from a human. So that brings me to the specific task that we have launched commercially for the robots. So trench excavation is something that these robots are being used today on commercial job sites in both the US and Australia. Trenching was one of the first products that we rolled out because it's very good for robots. Basic, repetitive task that takes place over large quantities of earth. And so there's a big opportunity to create a lot of value in the construction industry, but it's also a particular task. It's narrow, it's focused, and so that we can make sure that we're deploying a product that works day one and that's reliable in the field. I think it's very common for a lot of technologies to try to take on too much and to try to over-engineer solutions, and what you end up with is more of a science experiment than an actual commercial product. And that's what we've really focused on as a company, to make sure that we are actually shipping products to the field that are useful for customers day in and day out. So on trench excavation, I'm sure many of you are familiar, but this is a critical piece of work that happens for any time you have buried infrastructure for large sites. And so the types of projects that Built Robotics has been deployed on tend to be large greenfield infrastructure projects as you can see from these pictures, you're in the middle of nowhere, and these are big scopes that are taking place over long distances. So pipelines for oil and gas, electrical cables for solar, wind, utilities, things like that. And one of the problems we're solving by working in such remote environments is that it's often very difficult to find skilled labor to work in these places. So a lot of contractors in many countries around the world are struggling with a challenging labor shortage. And so our solution is meant to help kind of automate basic repetitive tasks. And so you can reallocate your skilled human labor to higher value tasks on the job site. The robots, they basically dig these at 130 to 180 feet per hour. So that's about anywhere from 30 to 45 meters per hour. And we can produce sloped sidewalls and clean walking surfaces along the trench. So contractors are finding that the output of and the quality of the work that these robots are producing is usable, and they're able to actually put the pipes and the electrical cables in the ground right after the robot. So you can see a couple more examples of what this looks like in real life. On the left here, you see really clean bottoms of the trenches, very consistent, very clean lines. And on the right, you can see how linear the spoil piles are. Some would call it robotic. And that's what these machines are very good at. When you have a computer digging, it is very precise, and it will do exactly what you asked it to do. And so the room for errors goes down significantly. You can ensure that the output of the work is within tolerance. And so these are some of the other benefits that we see from robotic solutions in the construction industry. We like to think of it as outdoor CNC machine. So once you've provided the parameters, the locations of where you want the task to be completed, the machine will go and do that very precisely. And here's one last look at a different type of trenching profile. So the trenches can vary in width. You can put a different bucket on it and dig wider, more narrow. You can dig deeper, shallow. It's fully configurable for the task that you have that day. And then it's also worth mentioning, I get asked a lot, can it dig curves? Can it dig not just straight lines? And the answer is yes. Basically, you need to provide the robot the endpoints, the GPS endpoints for where the trench needs to go, and then the robot will connect the dots. So why is this important? Why has Built Robotics embarked on this journey to unlock automation for the construction industry? And I think that's the theme of today. A lot of people are asking this question. We kind of boil it down to two big categories. The first, which is incredibly important, is that there's an opportunity to keep workers safe. If you can take operators out of the cab, out of harm's way, when you're doing a lot of these mundane, repetitive tasks, you essentially are taking workers out of the line of fire. I think we all take that very seriously. We want our people to be safe. And so we think of this as another tool in your toolbox. When it's appropriate, you can actually get the workers out of harm's way and reduce safety incidents. The second piece, of course, is transforming profitability. I think there's a lot of great data out there that shows that labor productivity in construction has actually decreased since the 1950s. We are an industry of innovation. There's been incredible, you look at the equipment outside, the engineering marvels that we've achieved as an industry are next to none. But I think in the last 30 to 50 years, while other sectors like manufacturing have embraced new processes, new technologies, construction has had a tough time to actually embrace some of those. And you can trace some of that to it is an operationally intensive industry. Taking risks can have incredible downsides. You need your projects to be delivered on time and to scope. And it's very, very hard to try something new. And so I think automation, though, is the next biggest thing after hydraulics in the construction industry. And it's going to really force us to rethink how we build. And in that process, if you can now run machines overnight, 24 hours a day, weekends, if they are precise, they're not making mistakes, you can really fundamentally rethink how we utilize equipment. And we can run equipment 3 times the hours in a single day. Well, that will change the economics of construction as well. And so we think that we can actually reduce costs, we can alleviate the pains of the labor shortage, and we can get a lot more done by utilizing new technology like automation. So as I described, what is this useful for? And I think it's very important to recognize the applications where new technology makes sense, and also be discerning about where it doesn't make a lot of sense. And so we as a company have actually found that applications like oil and gas, wind and solar, data center construction, utility construction is really conducive for the type of trenching that we do. What you'll notice is not on this slide is working in dense urban centers, working in congested environments. Autonomy is not quite ready for working in some of those confined spaces where the judgment, the eyes and ears of a human are going to be better. That being said, when you think into the future, we certainly believe this technology will continue to improve, sensor technology will continue to improve, and we will be able to address more and more of these cases over time. I do want to talk about safety, because this is something we've spent a lot of time as a company thinking about. And what we've come up with is actually a pretty sophisticated safety architecture. And I think one of the biggest takeaways from this slide should be that we've decided not to rely entirely on technology to ensure that these robots are completely safe. And I think in the philosophy of construction, having a multi-layer safety system is the best way to ensure safety. You want redundant layers that if something were to break through a single layer, there are other layers to actually catch it. So on the left here, you'll see that we actually have a combination of onboard and offboard safety systems to ensure that workers on sites are kept safe from the technology. So on the left, worker awareness. So we have both lights and sounds on each of our robotic excavators. So in the video, you probably saw those blue lights that are flashing. Those blue lights are a visual indicator that, hey, there's a robot at work. You should pay attention, be aware. And again, not to just rely on visual cues, we have a sound. We have a beeping sound that plays as well, and that is an audible cue. So just in case you're not looking at the robot, you can hear it, and you'll know that there's a robot working in the area. In the middle, we have a solution called Guardian. And so Guardian is actually a service that Built Robotics provides in its real-time monitoring that we're able to do remotely. So we get video streams from onboard cameras on each of our robots, and we basically have a control center where individuals from the Built Robotics team are constantly monitoring robots 24/7 around the world to ensure that when our customers are running robots, and if they want to leave a robot, it's running, and they can drive away, go do something else, you can leave a robot unattended and still have the peace of mind that someone is watching. And that's what we are able to do with the Guardian solution. Lastly, and most importantly, there are onboard solutions on the robot, safeguards that we've built into our technology. So the first is sense and avoid. So we use actually pretty sophisticated machine learning in order to run pedestrian and obstacle detection on each of our robots. So the cameras that are mounted on the unit are able to observe people and detect people from a safe distance. And if a person ventures into the vicinity of where the robot is working, the robot will stop. And if you're looking in the interface, there will be a bounding box that is drawn around on that person. And the way we've done this is we've actually collected a massive data set. We've trained our algorithms on a lot of different situations because construction's dynamic. Someone might walk in not wearing the same PPE that the model has been trained on. So we've taken a lot of pains and effort to ensure that we've actually covered all of the edge cases that might occur on a construction site. But the second layer that we build into the robots is a digital geofence. And so we upload GPS coordinates for the zone in which a robot will be working that day. So built into that software is if the robot encounters the perimeter of that geofence, it cannot work outside of it. It'll stop. And so that's another way to ensure that the robot is working in a set area that humans understand, and it cannot work outside of that area. On the other hand, we want to make sure that humans are aware of where the robot is working as well. So we actually put up temporary safety barriers. You probably saw it in that video, the orange tape that is kind of around the perimeter. That safety barrier is a visual cue for humans and workers working in the area of where that geofence is too. So humans don't enter that area, the robot knows not to leave the area. And finally, the last layer of safety here is an emergency stop. So we have wireless and wired emergency stops. The wireless stops work from a far distance. They use radio frequencies in order to safely stop the robot. These are safety-rated systems, and it is the fastest, most reliable way to stop the robot if anything were to happen on a job site or if you needed to stop for any unsafe conditions that are observed. So like I said, we didn't want to just be a science experiment. To us, building a commercial product that is useful day in, day out for our partners is very important to us. So we are fortunate to be working with some of the largest EPCs in the world, the likes of Bechtel, Mortenson. MPC Kinetic is a pipeline contractor in Australia that is using our robots. But the idea here is that we needed to get this tool into the hands of customers who are using this every day and who understand that how to use a tool and get as much value out of it as possible. And this is how we're changing the industry each day. Finally, who uses this? So Built Robotics is not actually, we're not a contractor. We're not sending our people to site and running these robots each day. We are a technology provider. And so we train the operators that our customers have on becoming robotic equipment operators. And this is a new type of work that is coming out because of these advancements in technology. So I think a lot of people ask, is automation mean that there are no jobs? And I think the answer is a resounding no. There are actually new jobs that are coming out as a result of automation. And the robotic equipment operator is going to be central to being able to effectively utilize robotic equipment in the future. So the robotic equipment operator is the person that we train who will supervise the robots throughout the day, ensure that when the robot needs to move to a new task, that sequence is performed, and that the robot is getting the right support it needs from the site. So if an area needs to be graded before you're going to be trenching, or let's say the pipe layer crew has fallen behind, you need someone who is in charge and who can help orchestrate all of these tools working together on a site. The types of profiles that we see that are effective for robotic equipment operators are obviously equipment operators. Surveyors and grade checkers are actually quite good at this as well, particularly because they are quite familiar using digital technologies like GPS. Finally, for Built, we're very proud that we've actually partnered with a lot of large players in the construction ecosystem, like the Association of Equipment Manufacturers, or in the United States, one of the largest labor unions, the International Union of Operating Engineers. They've partnered with Built Robotics so we can train their members on our technology. So we are here all week. We have a booth in the North Lot, FN 9145, and we are running a demo all week. So from our booth at bauma, you can send commands to a robot in either Australia or California. So from thousands of miles away, it's not just remote control. We do have that feature, and you can remote control those excavators. It's kind of fun. But you can also set it up for autonomous mode and press start and watch the robot work from thousands of miles away. And so we very much think that it's not just the future. These robots are out there, and we're hard at work trying to make this, bring this to market and scale it every single day. And we're very excited to be here with partners like yourself to help take our industry forward into the future. So thank you very much for the time. And if we have maybe a minute or two, if there's a question from the audience, more than happy to take it.
Yeah, is there a question from the audience? Yeah. Do we have a microphone somewhere? We had it before. Yeah, maybe I just can give you my microphone.
Yeah, hi. Thanks for the presentation. I'm Geir Ståle Kleppe from Steer, and we are retrofitting equipment to run dump trucks autonomously. Have you done other stuff than excavators, or and what other stuff machines?
Sure. So I think the question was, have we done anything other than excavators? And the answer is yes. So actually, the history of the company is the first type of equipment we prototyped was a track loader. And then we put a bunch of different attachments on it. So we put a blade on there, we put a breaker attachment on there, and we did a lot of pilot projects in the state of California to demonstrate that we can actually automate different types of equipment and perform different type of tasks with it as well. From there, we actually graduated into autonomous bulldozers, and we did a lot of finish grading activities with it as well. But ultimately, the excavator has become the workhorse platform for Built Robotics. And the reason for that is twofold. The first is that you can actually, excavators tend to work in isolated ways, or they can. Obviously, they're useful for loading trucks and working with other equipment, but they can also be productive if they're just digging trench on their own. And so we were able to find applications that are more conducive to autonomy by working on the excavator. And then the second piece is you can actually put a lot of different attachments on an excavator. It is one of the most common pieces of equipment on job sites. And so we found that if we focused our efforts there, we can actually unlock a lot more value for contractors around the world. So you can put a pile driving attachment on there, or a bucket, or a breaker attachment. And so that's what we're finding is we'll continue to develop and build out the ecosystem, and then over time get into more and more types of equipment as well.
Yeah, thanks a lot, Gaurav, for this nice presentation and exciting what is possible to retrofit such kind of machines. Thanks a lot, and yeah, hope to see your presentation live as well outside.
Thank you very
a lot.
much.